from the last book I wrote is the book actually that I will release with many publications somewhere at the end of this month or at the beginning of September. That's when we publish it. Now it's still in copy editing, but everything is almost done. So we will use this chapter together with some examples as you are used to with me already writing code in IntelliJ. And of course, as usual, please do ask any questions. If you have during the presentation, don't hesitate to interrupt me. You can use your microphone, you can use the chat. I will just make sure that I always have the chat here so I can see your questions and answer them when you write them. So what is the Spring Data all about? So Spring Data is basically a project of the Spring ecosystem, and its purpose is to make your life easier with connecting to databases in general, persistence mechanisms in general. It's not necessarily a relational database. It can be a NoSQL technology as well. And the first thing I would like to mention about Spring Data is when you refer to Spring Data, make sure that you understand Spring Data is not one dependency, is not only one technology. Spring Data is actually a group of technologies, and depending on whatever technology, on whatever persistent technology you use, you will choose a specific dependency of the Spring Data project in your application. So that means that when you say Spring Data, it's basically maybe 12 or even more dependencies that Spring offers, and you have to choose the right one. Let me actually show you, because we'll anyway connect to a database, and starting by an example, I think is the best approach before going into some visuals and discussing the architecture of Spring Data. The examples that we will implement are not complex. I don't want to create something complicated from the business perspective. I want to focus only on Spring Data. But I would like to discuss all the interfaces, all the contracts, everything that's needed for you to know in terms of what Spring Data is, so that you can easily use Spring Data whenever you'll need to do so in an application. So I will create a Spring Boot project using Spring Initializer, and I can just say Spring Data E1. I'm not sure if we will create more than one project, but let's call it like this. And then the most important thing is going to the dependencies, and I will make it as a web application. So I will start by adding Spring Web, and I'm also going to use MySQL as the database management system for my today's demonstration. So let me add the MySQL driver to everything. But in terms of connecting to a database, now I would actually have multiple choices, and the simplest choice I could take is using plain JDBC, which is Java database connectivity. And you can take this this JDBC API in case you'd like to simply use directly JDBC to connect to the database. So what does that mean is Spring offers you, we are using Spring Boot, so it's working with convention over configuration. So that means Spring Boot would configure for me anything that's needed to create a data source. And by default, Spring Boot uses the Hikari pool data source, and it would allow me a JDBC template so that I won't have to just use that plain old vanilla JDBC the way we were using it from the Java Standard Edition with prepared statement, result set. I'm not sure if how much experience you have, but in the early days when we didn't have any tool to allow us simplify the way we work with databases, even connecting and running a simple query against relational database was something that could take 10, 15, maybe more lines of code, because it's quite verbose to use the JDBC, the JDK offers, the JDBC capability, the JDK offers, which are the vanilla ones. So usually application frameworks, and I will directly refer to Spring here, offer you tools to minimize the lines of code you write. And the JDBC API comes with the JDBC template, which is an excellent tool, but it still has its sins that I would like to discuss in comparison with Spring Data, because JDBC API is not part of Spring Data. So I just started with this discussion to have something to compare with later when we go to the Spring Data part. So instead of adding JDBC API, because I don't want to use vanilla JDBC and neither JDBC template, I would like to use a higher level implementation. And the more high level you go, the easier is for you to write the code. So that means you will write less code, but usually also the less capabilities to customize your code you have. So the more low level you go, the easier it is to customize, but more difficult to write because you have to write more code. The more high level you go, the easier it is to write the code, but the less possibility of customizations you have. So what I will add here is a Spring Data capability. And I was starting from telling you that Spring Data is not only one dependency, it's a project providing several dependencies, each one offering capabilities to connect to a specific persistence technology. So even if we discuss only about relational databases, if I will write Spring Data here, which will show me all the possible dependencies which are part of the Spring Data project of the Spring ecosystem, you will see that we have multiple choices even to connect to relational databases using Spring Data. And I will enumerate those that are a part of connecting to a relational database. And out of this, you will see that we have the Spring Data JPA, the Spring Data JDBC, and the Spring Data Reactive JDBC, which is the counterpart of JDBC in reactive applications. So even when we discuss relational databases, Spring Data is still not only one. You have three dependencies that Spring Data offers for relational databases. So three different approaches in which you can connect to a relational database using Spring Data. And then besides that, you have a lot more dependencies for NoSQL technologies. So when you use some kind of technology like, for example, MongoDB, you might know MongoDB because it's one of the most known NoSQL technologies. Very often used in a lot of applications. It's a document-based NoSQL database. Spring Data offers you a possibility to connect to easier to a MongoDB server using the Spring Data MongoDB dependency. And the same you have for Cassandra, the same you have for Couchbase, Neo4j, Elasticsearch, Redis, so on and so forth. And for some of them, you even have the reactive counterpart. So the one is offering you the possibility to connect to a non-reactive standard application, but you might also have the counterpart that allows you to connect and work reactively in a reactive approach with that same technology. So you see, you basically, when people think about Spring Data, they tend to believe it's one dependency, and a lot of developers, especially beginners, I see confusing Spring Data with Spring Data JPA, for most likely for the reason that Spring Data JPA is very, very often used in a lot of tutorials, demonstrations, articles, books. You find Spring Data JPA, which is very often also used in production-ready applications, of course, but I don't want you think that Spring Data JPA is equivalent with Spring Data. It's just one of the lot of parts or that the Spring Data project offers you to allow you connect to different technologies. So in my case, I would choose to use Spring Data JPA if I want to use Spring Data, and Spring Data behind the scenes use a JPA implementation, JPA being a specification, the Java Persistence API, and one of the most known implementations you probably heard about, Hibernate, which is also the default configuration for Spring Boot. So if I choose Spring Data JPA, then it means I will use by default behind the scenes Hibernate to connect to my database. But I could also choose to use JDBC, and then that actually means I would use directly JDBC. And that's basically what I used in the chapter of my book. So in this case, let's actually go for Spring Data JPA in our demonstration, while in the chapter where I will show you also the visuals, you will see that I have actually used Spring Data JDBC for my demonstration. And you might ask me, why did you use Spring Data JDBC and not Spring Data JPA? Is because the book is basically focusing on Spring fundamentals. So it's a book for beginners, and I didn't want to assume that anyone reading the book already know JPA, which is not quite a simple specification. If you will search the document, the specification document out there, you will see it's about 700 pages specification, usually quite difficult to know all of it. And even I, after many years of experience using the Spring, using JPA in a lot of projects that I've been implemented or consulted, I'm also certified in JPA, and still I can tell you with the hand by heart that I don't know everything. I'm sure I forgot a lot of things, and whenever I need, I always use a refresher to make sure that I remember all the important stuff, because it's quite big. So that's why in my book I didn't want to go by using Spring Data JPA, because I wanted the reader to focus on Spring Data and not JPA itself. Make sure that I take out as much as possible of the things that could have been overwhelming for the reader. So I'm going to create this project. Let me start it, and once now IntelliJ will download and index my dependencies. Let me go back to where it is, to the chapter, and I will show you first of all. Let's go. I'm not going to read you the chapter, of course. If you want to read it, you can access the book, and of course, if you do me the favor of buying it, please also give me a nice 5 stars review if you like it. But I'm going to go through the visuals and then a bit through the code using the Spring Data JDBC, and then we will try to use the Spring Data JPA alternative, and this way you will also be able to make a comparison between them. So Spring Data, this is basically, in this visual you see the where it's placed in terms of software architecture. So you might have different persistent technologies, but Spring Data is a high level above all of them. So Spring Data offers you modules to connect to a relational database, but it also offers you modules to connect to a NoSQL technologies such as Neo4j, MongoDB, Redis, Cassandra, all those that you have already seen when I created the project. So then any app logic will go over Spring Data that behind the scenes will use a specific persistent technology depending on the one you use in your application, of course. So if you want to go even more detailed, you would say if in an app that doesn't work with Spring Data, the app directly uses either JDBC, Mongo, Neo4j, and so on and so forth. When you work with Spring Data, it looks more like this. So you have the Spring App logic, and then you have Spring Data, and then Spring Data works over JDBC directly, but it also works over JPA implementations such as Hibernate, which itself is dependent on JDBC. So that's why you see it's designed like this in this diagram. Or you can use Spring Data for MongoDB and connect to a Mongo database, or you can use Spring Data for Neo4j and connect to a Neo4j database, and so on and so forth. So that's basically it. So what it helps you is having a higher layer over all the multiple technologies we have to connect to a database and persist our data. So for example, if we just take one of the examples, you can just use in your application Spring Data JDBC. And then, of course, if you work with a relational database, like in my example here, I have MySQL, I can use Spring Data JDBC that will behind the scenes directly use the JDBC provided by the Java JDK and connect to the relational database. I use MySQL in my case. Of course, it still needs to use the MySQL driver. Remember that whenever you use JDBC and any relational database, the vendor provides you the driver with the implementations that allow you connect to that specific database. So that's why when I created the project here, I also had to add the specific driver. So I added the driver for the runtime. Otherwise, no matter what you use, when you use a relational database, when you connect to a relational database, it's a must you have the driver. So going a bit back, I was telling you that in the chapter I used JDBC. So you will see that we have multiple interfaces for Spring Data. When you use Spring Data, you actually write no implementation. That's the most important thing to remember, and the nicest thing about Spring Data is that basically you write no implementation. You only write some abstractions, and Spring Data enhancing Spring is smart enough to implement these interfaces for you, and depending on some annotations that you use above the methods, it actually creates the implementations, and your application will use to connect to the specific database. So that's basically done through some dynamic proxies, which is mechanisms Java offered through Java Reflection, and Spring and other frameworks used for a long time. Basically, Spring Data creates a dynamic proxy implementing the specific interface, and based on the annotations you define, it knows how to connect to the specific persistent technology and create the queries to work with the data the way you design it. So the only thing you need in terms of code to do is basically write an interface that looks like this, and that will extend one of the interfaces Spring Data offers. And most likely the most known interface from the Spring Data contracts, the way we name them, is CRUD repository. CRUD repository being an interface that allows you operate easily with all the CRUD operations: create, read, update, delete. So that's the select, insert, update, and delete in terms of JDBC, in terms of SQL queries. And in one of the above diagrams, you would basically see exactly how it looks like. Sorry. In Spring Data, CRUD repository is somewhere here. So it's not the top level. The repository interface is actually the top level interface for the contracts Spring Data offer. By the way, it's named repository because that's how we usually name the responsibility in application, the object in application that has the responsibility connecting to a persistence layer. So this interface, basically the top level one, the repository, is actually a marker interface. Marker interface, it means it doesn't contain any method. So it just marks the contract part of Spring Data, is the top parent contract of Spring Data. But then CRUD repository that extends that contract adds methods, and is the methods for create, read, update, and delete. And then you can have out of CRUD repository even other contracts that are more particular. So again, a very well-known contract that is extending from CRUD repository is the paging and sorting repository. This interface adds the capabilities to sort and pagination and sorting to the queries from the CRUD repository. So in terms of selecting data, it allows you to create pages, which is something we very often use. For example, if you have a front end with a table, have maybe 1,000 records in the database you want to display in that table, you'll most likely not display all of them in one page. You won't like to simply take all that information because it's too much data. You would like to transfer them from the backend to the front end. So instead, you just create pages of 10 or 30 or 100, whatever fits for your application, and you take the pages one by one instead of taking all the records at once. And then depending on what you have, you might use specific interfaces. For example, if you added the JPA, the Spring Data JPA, as we did in our example, I will start soon coding. It comes with the JPA repository interface, which in turn extends the paging and sorting, which extends the CRUD repository, and so on and so forth. So the JPA repository basically offers you even more particular methods that are simply just referring to JPA, to a JPA implementation. So they fit well with Hibernate, for example. And then when you create your application, what you do basically is creating an interface and extending one of the interfaces, one of the contracts of Spring Data. You can basically, the minimum you need to extend is the repository. You can extend the repository. Spring Data, if you do so, Spring Data will understand your interface as being a repository interface and will create a dynamic proxy and dynamic implementation for it. But of course, you won't inherit any out-of-the-box method. You will have to define all by yourself. Or you can go and extend CRUD repository, and then you will get the CRUD operations, and those you won't need to redefine anymore. So it's very often we extend CRUD or something more particular because usually we need at least the CRUD operations. It's very unlikely that you wouldn't need them. So that's why you won't really see in a real world app often an interface directly extending the repository interface. So you will most likely see either extending CRUD repository, either one of the interfaces that are extending are particularizing that contract. So in my case, in my diagram here, I just assume the count repository extends from JPA repository. That's not mandatory. But in that case, if that would be the case, then of course it means the count repository will get all the behavior from JPA repository and the above contracts. That's basically the way it works. So now we can actually do that ourselves. So if I'm going back to my application, I'm just going to make sure first I define the connections to my database. So I should already have Workbench. I should already have started a MySQL server here. So let me check to make sure. So I'm starting Workbench, which is a client, and that will basically allow me to connect to my local server. And if I can do that, it means I already have a server. So now let's actually create our custom schema here. Let's call it Spring Data, because that's what we are discussing. And inside the schema, we will create a table for our demonstration. So let's say we create a table product that has a primary key ID. I will make it auto increment in MySQL, which means the DBMS will give the records value one by one. And then let's say we also have a name, which will be a string. I think about child 45 should be enough. I run the create table query, and now I should see the table here. And the table, if I just select the rows, you will see it's empty. which is expected because we just created this table. So now let's just make our Spring application Spring data source URL connect to our database. So it would be JDBC, MySQL, localhost, Spring data, the name of the database, and then we have Spring data source again. Username in my case is root. I don't have a password on this computer. It's only for my demonstrations, this database, so I didn't configure a password. But these three properties here should now be enough for Spring Data to create my data source. So now let's basically just assume we create an endpoint and we add a record into our database. See if we can do that using Spring Data and see what does that imply. So remember that we have selected Spring Data JPA, and that means we need to use Hibernate. That means we will need to define an entity, a JPA entity, and use that one. I will then, after writing the example with you, I will then go back to the chapter of my book and I will compare it with the way it works when you use Spring Data JDBC, and you will see basically that there I didn't have to do everything I did in this project, since in the chapter of the book I used the Spring Data JDBC, which doesn't imply having a JPA implementation dependency behind the scenes. So now, first thing I would like to create is a way to represent the product in my application. So that's what we call in JPA terminology an entity. So I will say entities. Oops, no, sorry, I wanted that to be the package and not the class itself. So delete it. So I would like to create a package entities, and inside it create my product entity. So entities, and inside it say product. And if you don't know what this is, it's not a big deal. It's still, you will still understand Spring Data, but as an idea, that's basically what we need to do if we use JPA. We define the entity, we use the specific annotations as defined by the JPA specification. And in my case here, I only have 2 columns, and I would have to represent each of the columns using a field in my class. Moreover, one of these is the ID, so I need to make sure that I use the ID annotation to represent it. And because I marked it as being auto-incremented, I also need to tell Hibernate that I'm using this strategy, which in Hibernate terminology is called the strategy identity generation. Where can you find a tool that creates a class from the database? Usually, I don't use that, Thomas. Thank you for the question. When I was using, for example, NetBeans, I know that NetBeans includes that out of the box, and I'm pretty sure that IntelliJ would have this kind of a tool. So if you will search into plugins here, I don't know plugins by heart, but if you search into plugins, I'm pretty sure you will find a plugin that does that. So something like JPA entities, I don't know, something like should be here if you search it. But in my experience, I basically never heard about anyone using a plugin and just leave it like it is. Because usually there are things that a tool cannot understand, the way you want to create some relationships, the way you need to annotate some fields. Using a tool maybe would help you have something and then work on that. But I would still recommend you write the annotations yourself. In my experience, that was always better. So I always found it easier and safer to just create the entities myself rather than use a tool. But if you really want a tool, I'm pretty sure you will find an IntelliJ plugin for that. So yeah, in my case, I will continue the old-fashioned way I'm used to, so that's creating them by hand. and I think name was the name of the other one. And then usually I prefer using Lombok to avoid creating getters and setters, but since I didn't add the Lombok dependency here, allow me create the getters and the setters for that. So now I'm just going to create a separate package. I will call it repositories. And in the repositories package, I will create an interface product repository. And in case of Spring Data, remember that's the finest thing. You don't create a class, you create an interface, and you will never have to write the implementation because Spring Data provides you the implementation. So the only thing you need to do is make sure you extend the Spring Data contract. So in my case, for example, I would say the JPA repositories. I would extend JPA repository because I'm using Spring Data JPA, and I say product and integer, which means I create a repository for the entity product having a primary key of type integer. Remember, you don't need, I've seen this mistake a lot, I'm not sure why, you don't need any stereotype annotation on an interface, never, you don't need that. So I've seen people even in tutorials showing that it's not right, so you don't need this. Trust me, any stereotype annotation has only one purpose in Spring, create an instance in Spring's context. That's something you will always put on a non-abstract structure, which is not an interface. An interface is abstract. Being abstract, it cannot create instances. So adding a stereotype annotation above an interface, it doesn't make sense. Technically, you can do that. Practically, it's no use to do that. So make sure you avoid this anti-pattern of adding a stereotype annotation over an interface. It doesn't make sense. And now, usually I would have a service, but to make the example simpler, let me just create a controller. I will basically create a REST controller that defines an endpoint that takes a product, and I will try to use that endpoint to add the product into a database. So I will name it product controller. And I will make this a REST controller. And I will just make sure that, so let me first make sure that I inject here a product repository. So yes, it might look confusing that I'm injecting a product repository even though I don't have any class implementing that interface, but remember that's exactly the Spring Data magic. The Spring Data magic is basically the Spring Data creates you an implementation of this interface, and you don't have to do that yourself. And it does everything it needs to do behind the scenes using Hibernate without you having to actually implement that. And I will prove you that works. So save product will be my method. And then say product pro, oops, what did I do here? Again, public void save product p, and we make this a post mapping on product path. If we are saving, then I really need to make sure I also make this method transactional. And the only thing I need to do is I would just say save. You see how easy it is, because being that product repository extends from Spring from JPA repository, it basically inherits all the methods already defined by the above contract, which also extends, as you have seen in the diagram in the chapter of my book, the paging and sorting. So it means it also takes the behavior from the contract paging and sorting, which in the end extends the CRUD repository. So basically, we already have, only by extending and creating an empty interface, and just because we extend the JPA repository, we don't even have to write anything. We just have out of the box all the behavior we have inherited from the from the less abstract contracts, like for example, save is one of them. So that will allow us work with the database without even writing a method, without even writing a query. you can write your custom queries, but if you simply use the basic operations, you don't even have to work with that. So see how Spring Data basically eliminates the boilerplate code here, how easy it is to work with Spring Data in this case. If I'm basically running the application now and I just have nothing else to do, I can prove that I can call the endpoint and save a product into a database, and the only thing I needed to do is add the Spring Data dependency and basically create an empty interface that extends one of the Spring Data contracts, and that's basically it. So extremely easy working with Spring Data. And basically, Spring Data offers the same fashion of working with a persistence layer with all the technologies I've shown you already. I'm using now here, I'm using it with Hibernate. You should be able to actually see this here. The Hibernate has been initialized because I'm using Spring Data JPA. If I would have used Spring Data JDBC, it wouldn't have created Hibernate. It would have directly used the JDBC. But the same philosophy you use if you work with a NoSQL approach like Mongo, Cassandra. In a lot of cases, you only have to basically just write a method or call a method, and that's basically it. And now just going to a post one, I can say post HTTP localhost and product, and then I'm expecting, oh, I just realized I have a bug here. Sorry, I should have actually said request body. So Spring needs to know where to take the product from. So I need to tell Spring that I expect the product to be delivered as a JSON in the request body. I don't have to explicitly say it's JSON because JSON is by default, but I need to specify where does it take it from. So I need to annotate the parameter with the request body, otherwise it won't work. So let me wait again for it to restart. And I'm going back to my postman, say raw JSON, and then I think the only thing I need to specify is the name of the product. And I'd really like to drink a beer now, so let's say it's beer. So 200, okay. And if I'm going here and rerun the select, you see that beer got into my table in the database, so extremely easy. If we want to compare this now with the way I worked with in case of Spring Data JDBC, you will basically see that I did almost the same thing here. I created, instead of extending the JPA repository, which is not the case anymore since I'm not using a JPA, the JPA dependency, I'm directly extending the CRUD repository. But by the way, if you trust me or not, I could have done that here as well. So if I wanted to extend CRUD repository, since I'm only using the save method, which is part of the CRUD repository, I can do that as well. So that's even the case for myself here, because nobody says that I necessarily have to extend the JPA repository. I can extend one less particular contract. But in my case, I would like to show you basically also some JPA functionality here. So let me stick with the JPA repository. I'm going back. Where is it? So and then basically it's again very easy. You just have to you just have to call it to use it. Now maybe you would like to ask me, what if I want to actually implement a query? Well, if you want to actually write a query, you just have to write a method in the interface. No implementation for it. So literally no implementation. Look at this. So if I say list of product, find products by name, I don't even have to write a query, and Spring Data will basically automatically create a query out of the method name, which find product by name would mean something like select everything from the class where attribute is. So as you see here, find entity by attribute, and then the value of the attribute in the parameter, and we return a list of that attribute. So in my case now, if I create here, say a public void get product, and we say get mapping product again slash and the path variable representing the name, not void here but list to see the products that we get, I would just return, say return product repository, find product by name of the name, path variable string name, and that will automatically, of course, if I correctly import everything, that will basically automatically know how to get the product by name. So I will do the following. I'm restarting the application. I will add one more product, and I will show you basically that you can use this, and it will know to make the select over the name of the product automatically without you having even to write a query, because Spring Data writes the query for you. So going back here, if I'm adding one more beer, one more product, say chocolate. One more beer would be also nice because we have different IDs and we can see that multiple products will be retrieved. So going here, you will see that I have 3 products, 2 beers and the chocolate. So I'm going back in my Postman and I will just say get localhost 8080 product slash beer. And what will this do is returning the 2 beers I have. See, no chocolate here. Of course, if I would go and say chocolate, it will return me only the chocolate, which is the product with ID number 2. And if I just say candy, it will return me an empty list because I have no candy in the database. So that actually proves that my method works. And again, how funny is that I didn't even write a query? If I wanted to write a query, I could have done so because Spring Data allows you to also write custom queries if you'd like. So you can use the query annotation for that. And I can say select P from product P, where P name is name, which is the, by the way, you can see here, this is the JPQL notation. Mind that in case you are using Spring Data JPA, you have to use JPQL queries. You won't use SQL queries because you have to use JPA terminology. So that's why the query looks like this. Is the JPQL way of writing the query. But in case, going back to my chapter here, in case you'd have used Spring Data JDBC, then you see that the query needs to be a SQL query, like the one, select everything from table name where column equals value. So that's why here you see I use basically the normal SQL, while in case of our example here, I had to use, this is JPQL. So it's the Java persistent query language, which is the SQL syntax used by any JPA implementation, because I'm using Spring Data JPA and not Spring Data JDBC. Yeah, so that's basically it. But in the end, the biggest advantage, or part of the biggest advantages of Spring Data is, one, you write a lot less code. So a lot less code. If I would have written this without Spring Data, then I would have at least wrote 15 lines of code for this method. But I only replace it now with a method in an interface. So all this complexity has been removed. It would not only have been the complexity of the number of lines of code, but it would have been the complexity of the fact that I would have needed to treat several exceptions. I'm not sure, again, if you have some experience with working with JDBC, you would know that the raw approach, the JDBC approach also forces you treating the SQL exception. So that basically means you'd have had to write try catch. It's a lot more code to write than using Spring Data. So that's basically how Spring Data helps it eliminating boilerplate code. So that's one thing. The second thing is that being higher level, you use the same philosophy of working for any kind of implementation. So now imagine you would have to connect to a MongoDB database. So if you didn't work with a MongoDB database, by now I can tell you that it's different than working with JDBC. The code is not the same, the name of the classes differ, the way you write the code is different to do an operation with Mongo rather than do it with any JDBC technology. But if you do it using Spring Data, you will basically have to implement it in a very similar way. So you will still have to define just an interface. You will have to extend a contract. In case of Mongo, it's not called JPA repository, but it's called Mongo repository. You would still just define a method, and eventually you would still just customize your query using the query annotation, just that inside you will have not a JPQL, and neither an SQL, but a Mongo syntax for that. And of course, depending on the technology, the persistency technology you use, you will have to apply a correct way of writing the syntax to select the query. Is it possible to use the framework with Kotlin? Yes, the answer is yes. Spring Data has nothing to do with the programming language itself. Basically, with any kind of Java framework, since Kotlin and Groovy and Scala, they are all of them languages over the JVM. You can use them with these languages as well. By the way, Spring Boot even allows you to select Kotlin out of the box. So if you'd like to just do that, when you create a project, instead of choosing Java here, you just use Kotlin, and that will work out of the box, and you can use any kind of Spring with Kotlin, not only Spring Data. So yeah, and any kind of Spring, any project of Spring, we can use it with Kotlin directly. With Spring Boot, it's even easier because you just select the language and it pre-configures everything out of the box, and you just write the project. Cool. Thanks for the questions, by the way. And yeah, basically, I won't go into many details. I won't like to go into more details than this, because what we discussed basically covers the essential. And we have even implemented a very short but demonstrative project. Nice to prove the way you work with Spring Data and to understand the most important things that Spring Data offers. But of course, as it helps you simplify your project, I do recommend you use Spring Data in your project. So if you have a Spring application, using Spring Data helps you benefit of this simplification, allowing you to minimize the code. Maybe in my example, it's not that easier to see because I only have a very short example, but in a real world, in a production app, we don't have only one query, and it's usually not a very simple select by one attribute. You will have multiple queries. Some of them will be more complex, requiring more parameters and so on and so forth. And when you have one method, you don't see that you minimize the lines of code that much. But when you have 100 methods, imagine if for every method you spare some 20 lines of code, then you will have a lot more lines of code less for an entire project. And if you will use Kotlin, even better, because then Kotlin is even less verbose than Java, and that will make your project even shorter. So about my book, thank you for asking, Thomas. I don't have an Amazon link yet, since it's still in copy editing, and the book will be released at the beginning of September, so in a couple of weeks from now on. But what you can do, if you want to buy it by then, you can search it on Manning.com, and you can take it from here until it will be released also in Amazon. So Spring Quickly is the book I wrote for Spring Fundamentals, which includes all of the essentials, including using Spring Data, as you have seen. This is the one. And if you want to go even deeper with Spring, my second book that you can also find on Amazon is Spring Security in Action, that goes into Spring Security quite deep. So Spring Security in Action is basically this one. And this one, you can find it also on Amazon. Yeah, I'm not sure I know by heart the link, but if you search Spring Security in Action, Spring Security in Action, Amazon, then should be somewhere here. Yeah, so it's this one. Cool. Otherwise, yeah, I think we can conclude here. Thank you very much for the questions. Thank you very much for your presence here. I hope you enjoyed the demonstration. By the way, I also have a YouTube channel with a lot of video materials, which is free, and the blog. So if you'd like to join me here as well, you will find a lot of details, not only about Spring, but Java fundamentals, Spring security, and so on. So join me on YouTube as well, and share the channel with others. And let's stay in touch. Find me also on Twitter and LinkedIn, and let's stay in touch and discuss later other subjects as well. Yes, you can find, so is there a session on Spring transaction? I'm not sure if on this group, but you can find transactions in Spring discussed on my YouTube channel. So there are some videos about transactional, transaction propagation, transaction isolation, how to use rollback, whatever other people asked for, concurrent transaction issues. So there are a lot of things that you will find on my YouTube channel. So hopefully they will help you. Just take it, give it a chance, take a look, see if you find there what you need. And of course, don't forget that you can ask me questions, and I try to create other videos based on your recommendations. Otherwise, again, thank you very much, everyone. Have an excellent day further. Have a good time for learning, and cheers. Bye-bye.